Next up, Pat Martens from Hydro Technologies is going to talk to us about installation of very early strength LMC overlays.
So I'm going to talk today about the installation of very early strength concretes. And I'm sure you can all relate to this photo here. We've got bridges in various states of disrepair. Some decks you find out there on your system are pretty rough. Some are just starting to begin to corrode and exhibit delaminations and spalling, various patched decks out there. But one of the things you struggle with probably is you get into areas often where you have traffic issues and congestion, and it's very, very difficult to get in and get out and get the work done. How do you handle it? Is there products out there that can handle it? And I'd like to say, yes, there is. I'd like to think very early strength latex concretes, they're being used by many states and they perform very well. Before I get into the very early strength latex, so I just want to talk a little bit about overlay systems in general. When we're talking about dense concrete overlays, there's certain things you need to consider. Strength for sure is one, but maybe not so much compressive strength, but really the bending strength of the material you're going to use, because usually you're using this in an overlay situation that's fairly thin, maybe 1.5 to 2 inches in thickness. So you need something that's going to be able to deflect with your bridge superstructure. So something that has some flexibility and it's able to resist crack propagation out there. Probably the most important thing though is the bond. You have to be able to get a good adhesive bond, something that's going to interlock and allow for a monolithic application of that overlay to the deck substrate and allow it to act as one unit. You want an impermeable surface, something that's going to keep the chlorides from penetrating down into the base deck. And you want something that's going to last. It's got to be durable, got to be able to resist traffic abrasion. You need good concrete practices out there to make sure all of these things are happening out on the job site and working together. What is latex modified concrete? Basically, it's a concrete that's just been modified by a styrene butadiene polymer. That gets introduced in through the latex as an emulsion, and it gets added into the mixing water, which helps to reduce the amount of water needed in the mix design. And in doing so, it's kind of acting as a water reducer, so it's giving you advantages of what a water reducer admixture would provide. Now, one of the things about latex concretes is they've been around a long time. They've been around for 50 years. Late 60s is when latex started to come out onto the market, and they're still out there working very effectively. Virginia, I think, installed one of the first ones back in the late 60s. They're still a big proponent of latex modified concretes. Mike Sprinkle out there with Virginia has done numerous tests on both conventional and very early strength latex mixes and speaks very highly of the product and its performance out there. Latex is manufactured by two companies, BASF and Trinseo, and we actually have a couple people from BASF here in the conference today, so if you come down to the Hydrotech Modified Concrete booth break time, you can chat with some reps from BASF if you're interested in knowing more about latex. But there's also maybe a lesser known third company out there, Vandelay Industries. If any of you remember the Seinfeld series, you might remember George aspired to become a latex salesman. So I don't know if we've seen a lot of Vandelay product out on job sites or not, but about latex in general. And when I'm talking about latex concretes and very early strength latex, really I kind of talk about them interchangeably as far as their properties, what they do. They work similarly, whether it's using an early strength mix or not. But these overlay systems are good in numerous applications. They can be used on new bridge decks to preserve your initial installation. You can go in on relatively good decks and prep the deck, fair to poor decks. So there's a variety of applications based on the condition of the deck that's out there, and latex will work in all these applications. It's just a matter of the surface preparation. It may be hydrodemolition, but it doesn't have to be. It can be a milled. As long as you have a good sound substrate to get the overlay on, it can perform. You can even do it in second generation overlays where we have an overlay that's outlived its life and it needs to be replenished. You basically remove the overlay and prep it and put another overlay system on it. It's not going to be a cure-all for everything though. If you have a deck that's in need of replacement, you're not going to solve it with a latex concrete. The early strength latex, it uses a calcium aluminate type cement with the latex modifier. So this is what allows it to basically develop an accelerated set time, 3 hours. You can go with a type 3 type cement. You can gain strength within a 24-hour period generally with a type 3 type mix. When are you going to use the early strength, though? That's the question. And it's basically going to be when you have critical, time issues. It's going to be when you have to get in there over a weekend. You've got very limited access to a work zone. Even overnights in extreme cases, we've seen this product being used in overlay and inlay type applications out there. So the mix design is really not that much different than the conventional mix design that we'd see for a Type 1. The only thing different is going to be your type of cement. We see the CTS Rapid Set cement as a very effective cement with this particular design. The water cement ratio is going to be just a tad higher. Slump's going to be higher. Strength is going to be achieved. You're going to get about 3,000 PSI break, give or take, in that 3-hour window. Some of the things to consider with the early strength mix, specs, of course, are going to be critical. You want to have a good, tight spec, and then your on-site inspection needs to be very good. You might think you have a good spec out there that's very easily attained, but maybe it doesn't read quite the way you think it should. Surface saturation and curing are extremely critical with these latex mixes, especially the early strength mix. You have to have a good saturated surface dry condition that you're putting the mix down on, and then you have to have an immediate curing with wet burlap during the curing period. You need to be able to lock that overlay in with moisture top and bottom. The conventional times for curing with a Type 1, it's going to be a 96-hour period with 48 of that being wet cure. But if you'll see down on the very early strength mix, 3-hour minimum wet cure is all that's required. Even the high early strength Type 3 is going to be a 24-hour wet cure. So that probably isn't going to give you what you want if you're trying to get a weekend application to work for you. Contractor experience is always helpful. Some states actually put into their specifications that they want to see contractors that have a certain amount of experience with the types, same size types of jobs that they are specifying. Hydroblast for surface prep, I think, is a really good idea on these very early strength latex mixes. You don't have to, but I find that it's a little added safety factor in there because you just get more bondable surface area for your mix to grab to. The other thing we found with the very early strength latex mix and the conventional Type 1 mix is you can actually waive the rebar clearance requirements around your reinforcing steel. The mix lays out really nice. It's very flowable, has good fluidity, if that's a word. Is that a word? I don't know. As long as you have good sound substrate and you're getting all that deteriorated concrete out of there, you can go ahead and apply that latex mix directly to that substrate. A little bit on installation of the VEC LMC. It is a mobile mix product. You're not going to ready mix these products. This is a look at where we've seen installations that I'm aware of. There may be some on here that I'm not catching, but you can see it's pretty heavily been in the Midwestern areas. And some of these are not necessarily DOTs, like Texas, I think, was in Texas Turnpike Authority. Iowa, actually, I was in Iowa last week, and they just did their first installation with the VES. I just throw this on here because this is the Poplar Street Bridge approach in St. Louis, which I was out there about 15 years ago and put that in. And I kind of keep tabs on that. That was the first one Missouri did 15 years ago, and it's still looking pretty good. I keep up on it. A little bit of service cracking, but otherwise it's performing very well. This happens to be a job in Louisiana outside, I think this is on I-10, outside district office there in Baton Rouge, where they came in and did overnight work. They essentially had a short time window. I think they could get in there and get about 200, 250 square yards per night with hydro and the early strength mix. Just got a short video here showing the application. You can see it's very flowable, just kind of flows. You'll see the laborer here, he's going to take his broom here and kind of move it around. Generally, you can back the mobile mixer right up to the finished machine if the deck is allowing that. But you can see he's taking that broom and kind of working that latex in there. The other thing he's doing is he's getting grout on his bristles of his broom. So he's going to take that and he's going to smear that now on the vertical faces of the like the construction joint there between the lane lines. You don't have to grout your surface with a hydroed surface. So if it's a milled surface, it's recommended that you use a grout ahead of your overlay. But for For a hydroed surface, you don't have to do that. You do want to try to grout the vertical surfaces, like around your joints and the barrier edges. And what you want to pick up here is the proximity of the finishing operation behind the finish machine. You can see right behind the finish machine, the bridge there for the tining operation. They're doing a wet cure tine here. They're right behind that finish machine. So there's really no finishing. Once you have your machine set, you've got your rollers and your drag pans. If you get everything set well, it should finish off and seal nice for you. Then you just, right behind that, you're raking that with the tining rake if you're wet cure tining. And then notice the burlaps right behind there on the bridge. So as soon as you can get past the finishing operation, you're tining it, you're putting the burlap to it. I just wanted to highlight this one here at Powhite Parkway in Virginia. This was a job, I think it was set up for 7 weekends of work. The contractor did it in 3. In this particular picture, the first lane is done on the right side. The center is where they're working. And I just wanted to highlight the quantities just to show you how much you can do in a weekend operation if you really put your mind to it. Here we've got about 15,000 square yards that was done over the course of 3 weekends. So about 5,000 square yards of bridge deck, 1,100 plus cubic yards of latex over 3 weekends. So you can do a lot of area. It takes a lot of coordination and staging, but you can really cover a lot. I wanted to show you this time-lapse video here. It's got some drone footage in it too. This was done in Columbus, Indiana. This was put together by E&B Paving, so I want to thank them for allowing us to use this video. You'll see the operation. This is done over a weekend, a Friday night. They're out milling on the bridge. They're actually doing 2 bridges at one time. They're doing the inside lane in each direction. And you can see the milling operation. Then you'll get a little better view here. If you look to the left, they're hydroblasting on that deck while they're milling on the bridge to the right. So they're kind of simultaneously working on both bridges. So there's not a lot of footage there of the hydro demolition. The deck work the prep has been done as far as the hydro work, and they're out on the deck now prepping. You can see where the rebar's exposed. That's where the selective removal has occurred within both of the bridge decks through the hydro demolition operation. And then the rest of it here is going to be the installation of the latex concrete. So here they're at their staging yard loading up their mobile mixers. And you see your army of people out there, so you get a pretty good idea of how many people they have on these jobs. It's important to have a lot of people out there to make sure you're covering all your bases out there. But you can see how close the finishing operation is. That's a good overall view from the top side. You can see the dispensing of the latex, and then how close the machine is with the curing operation immediately behind that. And they're also pulling up the plastic, so that's important too. You get your wet cure started and get that plastic pulled on there too to lock in that moisture and keep any evaporation from happening there. And here's just a look at the kind of the work zone and how the trucks were all staged through there. So you have a pretty tight work area too to have to negotiate and get your equipment through. So there's the final product. You can see they've got it open on, that'd be Sunday afternoon. So over the course of a weekend, they were able to rehabilitate that particular set of bridges right there. So I want to touch briefly on something we have out there, just started here, called the LMC Working Group. We put together a group of experts in the field, basically. We've got producers and suppliers, latex suppliers, we've got engineers, contractors. We've got a mission statement we developed, and I want to especially draw your attention to the third bullet, developing and conducting training programs for designing and installing LMC overlays. That's something we think is very important within our group. We think that's been an issue maybe through the years with latex and some issues that have happened on some jobs, so we want to make a point to be much more active in that area. And we're working through the TSP2 group. There's a working group out there, the National Bridge Deck Preservation Working Group that Steve Austin is heading up. So we're kind of under their wing and working out there to put together material. And Greg had mentioned about the pocket guide. We think that could be very helpful for us. But a lot of what we're going to do is going to include education and training with regard to the materials that are being used, batching, placement and curing, and even the equipment, and then monitoring the performance too. And then we get back to George. And then just one kind of a food for thought here. I seen this the other day. A shark in a fish tank will grow 8 inches, but in the ocean it will grow up to 8 feet or more. The shark will never outgrow its environment, and the same is true about you. Many times we're around small thinking people so we don't grow. Change your environment and watch your growth. So I just thought that was kind of an interesting, kind of inspirational message, because as I look at the map, I noticed in the Northeast, there's not very many orange states there. So maybe you need to kind of get out of your comfort zone and your paradigms and look at opportunities for a process like this.
What's the maximum thickness you can do with the VELMC?
It's been poured pretty thick. It's been poured in 10, 12 inch layers, but generally it's going to be 1.5 inches minimum. And you'll usually find it in the 1.5 inches to 2 1/4, somewhere in there is generally where you're going to place it. It just gets pretty expensive when you have to start placing it in really thick lifts.
Yard?
Well, the cost of material, it's probably going to be in the range of about $900 to $1,000 per cubic yard is what I would guess I'm going to see, because I know in Missouri we try to put that in our quotation as far as our bid package. So if we have excess overrun, we'll just pay it as kind of like a change order type, our cost overrun like that. So it's probably going to be about twice the cost of conventional latex, I would guess.
Let's give Pat a hand. If you have any questions, he's downstairs, like he said. So.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.